All right, let's take a look at this one. Again, the numbers for your problem might be slightly different. We're looking at the solving and giving the exact solution to this exponential equation, 5 to the 5x minus 3 equals 35. So the way I'm going to proceed with this is I'm going to use the natural logarithm. You could use log base 5 in this case to solve. But again, I'm working on the assumption that if we wanted to approximate the solution, we would you need to use a calculator or some technology. And a lot of them only have, for instance, on the 80, 83 and 84, they have the ln and log, so log base e, log base 10 button. I know some of them do have log base anything button, but let's work on this idea using the natural log. Um, so I'm going to take the natural log of both sides, and I'm going to start using some properties of logarithms. If you remember, we have these three properties for any log base, this is for log base e. The natural log is true for log base 10, log base 2, whatever. The log of a product is the sum of the logs. Again, remember logarithms are exponents, and so when we're multiplying like bases to different powers, we add the powers, we add the exponents. The natural log of a quotient is the difference of the logarithms, and the natural log of a to the n, right? Think about uh, the exponent, what would it be here? When you raise a power to another power, we multiply, right? So it's n times the logarithm, n times the power on the base needed to get a. So we kind of think of this property as bringing the n down is what's going on when we're going from here to here. So we use these properties, and I'm going to make use of this last one, number 3, this third one, to bring the exponent with n, which is 5x minus 3 in this case. I'm going to bring it down in front like this. So I've got 5x minus 3 times the natural log of 5. Remember, this is just what is the natural log of 5? It's the power of e needed to get 5. I mean, it's some number. You can use your calculator to approximate it. Equals, of course, the natural log of 35. And I put it in parentheses just to emphasize we're taking the logarithm of that quantity. Generally, we write them without the parentheses, but either way. So now I want to solve for x. So how do I do that? Well, remember, natural log of 5 is just a number. So I'm going to divide both sides of this equation by the natural log of 5. And then to solve for x, I'm going to add 3. And then what I'm going to divide by 5. So I need to divide both of these by 5. So I divide this one by 5, and 3 divided by 5 gives me that. Now this is a solution. This would be an exact solution. They're asking for an exact answer. You can use your calculator to approximate, this, but we can actually simplify this a little bit better. If you'll notice, the natural log of 35, right, can be simplified further. Remember this property up here? If I can write 35 as a product of two things, for instance, 5 times 7 is 35. And why is that helpful? Well, natural log of 5 times 7, a times b, is the natural log of a plus the natural log of b, where a is 5 and b is 7. All right, so using that first property. So how does this help? Well, if I rewrite natural log of 35 as that, notice I can break this fraction up into two fractions, the natural log of 5 divided by 5 times the natural log of 5, and the natural log of 7 divided by 5 times the natural log of 5. And the point is this, and can be simplified, right? Natural log of 5 divided by natural log of 5 is 1. And so this whole fraction here is 1/5. And so this simplifies. 1/5 plus 3/5 is 4/5. And then we still have this thing, which I'll write now, natural log of 7 divided by 5 times the natural log of 5. So this is a little bit more compact form for the exact answer. Now you can approximate this in this problem. This is what they want. They want the exact answer. We can approximate this with the calculator. So I'm going to do this as the natural log of 7 divided by the quantity 5 times the natural log of 5. Okay, there's that first fraction, plus 4/5, which is 0.8, or you can do 4 divided by 5. And so this is the approximate solution. And notice you can double check this in your calculator, because if I plug in this value of x in for x here, 5 times this quantity minus 3, and then raise 5 to that power, I should get 35. Let's see if that's the case. 5 raised to what power? 5 times that value of x as just answer. So I'm going to do answer minus 3. Okay, so this should come out to 35 if this is correct. It is, and there it is. But again, in this problem, they want the exact answer, so they want this, but sometimes we ask also for a decimal approximation. Okay, hope this is helpful.